Good morning. Today we will complete the second lesson. Today we complete the second lesson about graduation of elements, properties, and the modern periodic table. We will make a revision on what we study in this lesson and we completed it. We study that the elements have properties and it's graduated in the modern periodic table. From these properties, we have studied three properties. First one, the atomic size. What happened to the atomic size? The electronegativity property and metallic and non-metallic properties. And we talk about the atomic radius or the atomic size measured by unit picometer. And its abbreviation PM. Picometer is abbreviation PM. It's part of million part of meter. Equal 1 times 10 over minus 12 of meter. And the atomic size, it's decrease as we move from left to right in the period. And the atomic size increase as we move from up to down in the group. So the atomic size decrease in period because the number of atomic number increase, the attraction force between the nucleus and electron increase, so the size decrease. But in group, the atomic size increase because the number of energy level occupied by electron increase, so the atomic size increased. And the element that has the largest size in the table of the elements, cesium. Cesium has the largest size, and it's located in the bottom left of the modern periodic table. What about the smallest size element? It was fluorine, the smallest size element, and located in the upper right side of the table. And the element in group 1A has the largest atomic, has the largest size. So the group 1E element has the largest size element in all the modern periodic table. That we will study about the atomic size and relation between the atomic size and the number in period are inversely proportional. When the atomic number increase, the size decrease. But the atomic size and number in group between them directly proportional. When atomic number increase, the size increase. So we call directly proportional to each other. The second property we'll talk about the electronegativity property. We study that the electronegativity comes from its name, the negative charge of electron. And we say that the element when make a reaction, is form a compound. When there are covalent molecules, but the elements are different, like carbon dioxide, like water, like ammonia, there are different type of element, so it's called covalent compound because between its atom covalent bond. And the electronegativity, it's the ability of the atom in the covalent molecule or compound to attract the electron of the bond towards itself. And we study that the inert gas doesn't have electronegativity because its outermost energy level completely filled with electrons, so it doesn't combine with any other element because it's stable, doesn't need to make a reaction, doesn't react, so it doesn't have electronegativity, it doesn't form it bond. Because the electronegativity, it's happened in the covalent bond of the compounds. And we study there are three types of compound. Polar compound, when the a compound have different type of elements, like water, like ammonia. Non-polar compound has the same type of element, but it must be covalent compound, have covalent bond. Like the oxygen molecule has the same type of element and have covalent bond between two oxygen atoms. but we call non-polar compound because the difference electronegativity is zero. Ionic compound that has metal and non-metal between metal and non-metal ionic bond. So the polar compound, it's covalent compound because has covalent bond between its atoms, which the difference in electronegativity between its element is relatively high. So the polar compound, the difference between electronegativity between two atoms is very high in the compound. And we have two examples of polar compound. Water molecule, simple H2O, two hydrogen atom combine single covalent bond with oxygen, and ammonia molecule in H3, one nitrogen atom combine also with three covalent single covalent bond with a three hydrogen atom. And the electronegativity of oxygen 3.5. Hydrogen electronegativity 2.1. So the difference between the electronegativity between oxygen and hydrogen equal 1.4. But what about the ammonia? Ammonia, the nitrogen has electronegativity 3 and also the hydrogen 2.1. So the difference between electronegativity between nitrogen and hydrogen equal 0.9. So the water has more difference in electronegativity than ammonia molecule. Both of them are polar compound because the difference electronegativity between its elements is very high. But how water has more electronegativity, has more polar compound than the ammonia because the difference electronegativity in water molecule between oxygen and hydrogen larger than between nitrogen and hydrogen and ammonia molecule. That was about electronegativity. And the third property, we talk about metal and non-metallic properties. We classify the element according to its physical property and number of electrons in outermost to four types. Metal, non-metal, metalloid. We call it semi-metal. It has same some type of property of metal, so we call it semi-metals and noble gas. We say the metal is the element which have less than four electrons in the outermost, and it when make interchemical reaction because it's unstable, it needs to be stable, so it interchemical reaction to complete the outermost with electron. So it lose their outermost electron and it change to positive ion. Why positive ion? With the number of positive protons larger than the number of negative electron because it's lose electron. Why it has positive ion? Form a positive ion to reach the electronic configuration of the nearest noble gases or inert gases preceding before it's in the above period. So it's changed to positive ion. And the positive ion, it's atom of metallic element, which lose lost one or more electron in chemical reaction. And we see it have positive charge, number of positive charge equal the number of lost electron, like sodium, magnesium, aluminum, all of them are metal because have less than 4 electrons in the outermost, and when it's in chemical reaction it lose the outermost electron and change to a positive ion carry the positive charge about the number of lost electrons. Sodium lost one, so positive we don't write one. Magnesium positive two because it lost two electrons. Aluminum plus three because it lost three electrons. And their electronic configuration after losing the electron is similar to the neon, which has same to neon electronic configuration, and the neon it's located preceding the all of this element in the above period. But about non-metal, it has more than 4 electrons in the outermost, and It's also unstable. We need to change or complete the outermost with electrons, so it's enter chemical reaction, but change it to negative ion because it gain electron when enter chemical reaction. Why it changed to negative ion? To reach also to the electronic configuration of the nearest energy gas, but not preceding him, follow him after him in the next period. And we called it negative ion because it has electron more than the number of proton because it gain electron. And the negative ion, it's atom of non-metallic element which gain more than one electron and one or more electron in the chemical reaction. And the carry number of negative charge equal to the gained electron, like phosphorus, sulfur, and fluoride. All of them are non-metal because they have more than 4 electrons in the outermost. And when the phosphorus gain 3, it have minus 3 because it gain 3 electrons to complete from 5 to 8. The sulfur have minus 2 because it gain 2 electrons. Fluorine minus 1, and we don't write 1 because it gain 1 electron from the outermost. And all of them has the electronic configuration of the argon, and the argon located in the following period, the period before them, sorry, after them, in the modern period. So the fluorine, so the phosphorus and sulfur and the chlorine had the electronic configuration to the nearest energy gas, which was argon, in the following period or the following them in the modern period. And the difference between positive ion and negative ion in the number of electrons. It's a positive ion, it's a metallic element, loses electron, but the negative ion is non-metallic, gain electron. The number of electrons in positive less than proton. The number of electrons in negative more than proton. The energy level, number of energy level in positive ion decrease less than the neutral ion because it lose energy level, or electron the energy level. The negative ion, the number of energy level in negative ion equal in the ion and in neutral atom. So what is the difference between the positive ion and negative ion? Metalloid. We call the metalloid semi-metal. It's located in P block between metal and non-metal. Also, the metal located in the left side of the table, non-metal located in the right side of the table, noble gas located in the last group, in the last group in the maximum right side of the table. Metalloid between non-metal and noble gas between non-metal. Sorry, in metalloid between metal and non-metal, between metal and non-metal. So the modern periodic table what is the location of metal and non-metal? The metal located in the left side of the table, the non-metal located in the right side of the table, the noble gas in the maximum right side of the table, metalloid between metal and non-metal, between metal and non-metal. What about the metalloid? What's meant by metalloid? Metalloid is element located in block B, as we see, all of them, the yellow color in here is metal. The dark yellow color is metalloid between metal, and the violet color is non-metal, and the energy gas in the maximum right. So the metalloid between metal and non-metal. So we call it semi-metal because it has some of properties of metal and some of properties of non-metal, and they are which have properties of both metal and non-metal. They are 6 elements: boron, silicon Si, germanium symbol Ve, arsenic symbol Es, antimony Sp, chlorine Te. They are metalloid between metal properties and non-metal properties. What happened the metallic non-metallic property in the modern periodic table? As we start in the modern periodic table, each period starts with strong metal because the metal are located in the maximum right side or the right side, sorry, left side of the table. All of this faint yellow are metal, but the strongest metal like in putting in one envelope. So each period starts with strong metal. As we move the metallic properties, because they are strong metals, so the metallic properties as we move in the way in the period, decrease reaching metalloid. Then after that, it's starting the non-metal property in period increase. So the strongest non-metal 7A or 17 group. After that, the noble. So each period starts with strong metal except period number 1. As hydrogen non-metal and the metallic property in period decrease to reaching the non-metalloid. After that, the non-metallic property increase to reaching the strongest non-metal 7A group or 17. Then the 18 or 0 group, its Maynard gauge is the maximum right side of the table. This is the shape or element type in the modern periodic table. And we see the metallic property in period increase. So the number, so atomic number in period increase. The atomic size as we move decrease. The electronegativity as we move in period increase because the electronegativity related to atomic size. Size decrease, electronegativity increase between nucleus and outermost electron. And the metallic property decrease. But in group, as we move down, the atomic size, so the atomic number in group increase, the atomic size increase also. Electronegativity in group decrease because the size increase, and the metallic property as we move down increase, and non-metallic property as we move down. So the metallic property in period decrease, and non-metallic property in period increase because the metallic property opposite to non-metallic property. Metallic property in group increase, but non-metallic property increase. This is all about the property of element in modern periodic table. We will study the chemical properties of the metal, and we see that the metal tend to interchemical reaction. So it reacts with dilute acid, and we call dilute acid because it added water to it, not concentrated. When any metal like magnesium react with dilute HCl, have the caloric acid, it produces salt of acid. Salt of acid, and means a salt is between positive ion and negative ion, and hydrogen gas evolved. What sound of something make the small sound. This is when the action with metal and dilute acid, salt of acid formed, and hydrogen gas evolved with both solid. But when the metal react with oxygen, when the magnesium also reacts with oxygen by burning the magnesium ribbon or magnesium bar of magnesium with fire, we burning it, so it reacts with oxygen around it in the jar. And what happened? White powder formed in the bottom of the test tube. This white powder called the magnesium oxide. When magnesium reacts with oxygen, it formed magnesium oxide. We called it metal oxide because the magnesium metal, and also called basic oxide. We will call it basic oxide because when we adding water to the magnesium oxide that formed, it formed solution but called alkaline solution because it's alkali base, because has hydroxide So when metal or any magnesium or metal react with oxygen, formed magnesium oxide, metallic oxide. We call them basic oxide. Why? Because when adding water to the metallic oxide, form solution called alkaline solution because had base or alkali, it's called hydroxide ion. And when we wanted to check it, we use litmus solution. Litmus solution, when we adding to alkali or alkaline solution, change from violet to blue. So we make sure that it was alkaline solution. And the basic oxide, they are metallic oxide when dissolved in water, forming alkaline solution, as we see in this experiment. And we see the metal have activity, and uh, some of them putting in series called in chemical activity series. We arrange the metal according activity from the largest to the smallest activity, okay, according to reaction with water vapor. And it's called chemical activity series. It's arrangement of metal, of metal. Descending order according to degree of their chemical activity. How it's act with water or water vapor. Potassium and sodium react instantly as soon as it's exposed to water, and hydrogen gas evolved with both sound like that exploding. Calcium and magnesium react with cold water but slowly. Take long time to make a reaction. Zinc and iron react with the water vapor in the air at high temperature. So when the iron and the zinc exposed to the flame, it react with water vapor only. Copper and silver doesn't react with water air because they are inactive metal. This is called chemical activity series. What about non-metal? Non-metal react also. How it reacts with nitric acid and oxygen, like metal. When we putting piece of coal, it has carbon, like a coal that we use in barbecue party, make a meat on it or chicken. Its coal is made of carbon elements. Carbon is non-metal. When we adding coal or carbon to dilute hydrochloric acid, there's no reaction happen. So the metal reacts with dilute forming salt of acid and hydrogen gas evolve with both sound. But the non-metal doesn't react with dilute acid, as we see in this tube. What about reaction with oxygen? The non-metal reacts with oxygen like metal, but the difference when the non-metal like carbon burning and the putting in jar is react with oxygen around it, forming non-metallic oxide. Non-metallic oxide. So when non-metal like carbon react with oxygen, forming non-metal oxide, and we call it acidic oxide, not basic one. So the carbon or non-metal react with oxygen, forming non-metallic oxide, which called acidic oxide. Why we call the acidic oxide from this name? Why called acidic oxide? Because when dissolved in water, forming acid. And acid start with positive hydrogen ion. So the non-metal react with oxygen, forming the non-metallic oxide, called acidic oxide. Like carbon dioxide when formed between carbon and oxygen reaction. When the carbon or coal burning, a fume coming from it, this we call the carbon dioxide gas. This carbon dioxide called the non-metallic oxide and the acidic oxide because when dissolved in water, it's form carbonic acid and this acid because starting with hydrogen ion. We call the acidic oxide because dissolved in water forming acid. Why we check it? When we use litmus solution, it changes from violet to red. So the basic oxide or the alkaline solution changes litmus from violet to blue, but in non-metallic change from violet to red. There is a difference between metal and non-metal reaction with oxygen. So it's called acidic oxide. Why the acidic oxide? They are non-metallic oxide which dissolve in water forming what? Acidic solution, acid. But there are some oxide which not metal and non-metal oxide called amphoteric oxide. So the aluminum oxide called amphoteric oxide, not called the basic or acidic oxide. Why it's called amphoteric oxide? Because it reacts with acid as base and react with base as acidic oxide, giving in each case salt. So the aluminum can react as a base and acid, so it's called amphoteric. So the aluminum react with the acid as a basic oxide. So it can be metallic oxide and can be non-metallic oxide. So when react with acid forming the basic oxide as a basic oxide. So why you call the aluminum amphoteric? Because it can react as basic oxide and acidic oxide. React with acid as a basic oxide and react with base as acidic oxide. And each case when base and acid react is forming salt and water. Salt and water. This is metal and non-metallic difference between metal and non-metallic and between basic oxide and non-basic and acidic oxide. The metal has less than 4, non-metal has more than 4 electrons. The metal lose electron change to positive ion, non-metal gain electron and change to negative ion. The metal has largest size and the metal has smallest size. The metal react with dilute acid. Non-metal doesn't react with dilute acid. Metal and non-metal react with oxygen, but the metal forming a basic oxide and acidic solution, and metal form acidic oxide and acidic solution. This is the difference between metal and non-metal. We will answer some questions. Okay. In the same period, the increase in the atomic number. What happened in the period when the atomic number increased? What happened to the size? It decrease or increase or doesn't it change or the atomic radius increase? What will it choose? In the period, the atomic size decrease. This is the right answer. This is the right answer. Number 4, which of the following element is metallic? If we know it's metal or non-metal, we can make electronic configuration. The magnesium, first one has 8 electrons, has 2 electrons. The second energy level L has 8. The third M has 2 electrons. 2, 8, 2, it's 12. That's right. Chlorine 17, the first has 2 electrons, second has 8 electrons, third has 7 electrons. So we can make a sum of them are equal 17, so it's right. Oxygen, the first has 2, second has 6. Neon, it's 10, we can, the first one has 2, second has 8, because some of them are equal 10, that's right. So the metal has less than 4 electron in outermost, and 4 has less than electron, 4 electron. The magnesium has less than 4, 2 electrons. So it's metal. Okay. And element X, whose atomic number 13. The number electron, it's ion, and metallic, the element X has atomic number 13. 13, so the electronic configuration 2 in the first energy level. L has 8 electrons, third has 3. So the sum of them are 13. 2, 8, 3, 13. So it's atomic number 13. It has 3 in outermost. 3 meaning metal because close the 3. So its ion when losing the three change to losing the three um, electron outermost, and its electronic configuration of ion, it will be 10. Okay. Okay. Um, if you know the atomic number of element 11, it's atomic number 11. Okay. If you know the atomic number 11, which of the following represent the configuration of its ion? 11, so has 2, 8, 1 electron. So it has one in the outermost and it lose it. So it change to element has 10 electron in outermost. So that is the right answer. It has 10 electron. Its ion has 10 electron. We can answer mm, some problem. Okay. The atomic size of lithium that has three atomic number and nitrogen 7. 3 and 7, so the nitrogen after lithium in the period. Okay, so atomic size. As we move it, what happened in period? It's decreased. So the size of lithium will be larger than the the nitrogen. And between sodium and lithium, lithium 3 atomic number and sodium 11. So the number of energy increase, so the lithium and sodium, sodium after the lithium in group, after the lithium in group. As we move in group, the size increase. So the size between lithium and sodium, so the lithium smaller than uh, sodium because it is after him, sodium after lithium in sorry in group. So lithium, sodium, they are same group. So the lithium smaller because the atomic size increase as we move in group, but it's larger than nitrogen because the atomic size decrease in the period. Okay, what? and answer again. You can answer this table. Sodium has electronic configuration 2, 8, 1, okay, and magnesium 2, 8, 2 because it's non-metal. Carbon, it will be 2 and 4. Okay, it has one electron, so it's metal. It has two electrons, so also metal. Less than 4, it's metal. It has more than 4 or equal 4, it's non-metal. Its formula is oxide Na2O. The magnesium formula, the magnesium oxide, its symbol MgO. But we write the formula as the number of valence. We know that a magnesium has valency 2 bivalent and also oxygen bivalent. So they are cancelled with each other. This is the formula. But when they are the same, we cancel 2 with 2. So we cancel. So this is the formula of magnesium oxide. The carbon oxide, its formula CO. But the carbon the carbon is tetravalent, and we write it on the next atom. So we write here 4, and the oxygen divalent. So we write it in next. So we write the valency in the next bottom of the next element. So carbon tetravalent 4. We write in bottom of oxygen. The oxygen divalent. So we write it in carbon bottom of carbon. So 2 4 we can divide it by 2. So it will be 1. Here we don't write 1. So this formula of carbon dioxide. Type of oxide. Sodium oxide, it's metal, so called the basic oxide. The magnesium oxide is also metal, so it's called the basic also oxide. The carbon dioxide, it's non-metal, so it's called the acidic oxide. Okay. There are for today. Thank you. We will starting with the next lesson and the next session. Thank you.